The Mastervolt MLi 1250 is Mastervolt's 12 volt, 100 amp hour, 1250 watt hour lithium iron phosphate battery. This advanced systems integrated battery has master bus, C-zone, and NEMA 2000 communications capabilities, as well as an analog output that will output 0 to 10 volts based on state of charge. So 0 volts at 0% state of charge, 10 volts at 100% state of charge, as well as an auxiliary relay that can be used to signal external devices. That might be to signal charge control. That can also be used as an early warning to signal an alternator to stop charging because a disconnect event is coming, etc. The MLi series of batteries underpin Navico's Fathom e-Power generator replacement system. E-Power relies on the MLi's advanced communications capabilities in order to coordinate charging and discharging, conversion, and all of the various functions that go along with the Fathom e-Power system and their harnessing of engine alternator output in order to replace a generator on board. Let's take a look at the MLi 1250 and the build quality associated. So to do that, we'll start by tearing it apart. Step one is going to be to remove the handle and then remove the screws from the case. Case is held on by 7 3mm hex head screws. So we'll go ahead and take those out. Screws are out. Let's pull the lid. We find staring us right in the face is the BMS on top of the cells. A pretty highly customized BMS. Looks, like an entirely custom-made part. Mastervolt silkscreened on the board. Looking at the BMS overall, find the negative pole, positive pole, a connection over here. I believe that is going to the relay or contactor that is used to control power to the battery. It's worth noting this is not a FET-based BMS. This is a contactor-based BMS. So it's an all-on or all-off connection, but it's also a very discrete and positive control of the battery's charge and discharge. Charge and discharge are going to be controlled together because there is a single contactor controlling all aspects of the battery. Let's go ahead and pull the screws that are holding the contacts from the BMS onto the cells. So we find here 1, 2, 3, 4, 5 connections to the cells for the 5 posts, basically, 5 bus bars that connect the various cells. I see here that we have what appears to be, so this says temp D, cell D, temp B, cell B, temp A, pack, cell A, cell C. So we've got 3 temperature probes and the 5 voltage probes for each individual cell pair, as well as the pack overall, right? So we've got a pack over here, and then there's we're getting ground over here, or sorry, positive over here. So we've got negative here, positive here to get the full pack voltage. Let's loosen that guy up. So right here we have our negative connection, and I see these wires tells me that this is our shunt, right? Because they're measuring for voltage drop across the shunt, and the little notch out of there makes me think that's a calibrated piece of metal with a predictable voltage drop based on current. So that's in place there. Can we get that out? I'm not able to release that. I don't really want to break it, so we'll just leave it attached. Remove the heater cable. Yep, BMS is off. Let's pull the positive. Now we've got the 4 bolts that hold the cell pack down. So go ahead and release those. Okay. Number 1. Okay, so we see that we've got 1, 2, 3, 4, 5, 6, 7, 8 cells, 4 series, 2 parallel connections. Bus bars are laser welded onto the posts. Makes for a nice, clean, well put together pack. I see cell compression stiffeners on each end. In terms of looking at what the cells are themselves, let's see. I think the best way to do this is going to be to go ahead and pry up this metal a little bit and reveal the QR code. So there's our QR. Let's go ahead and scan the QR. There we go. Okay. So these are 50 amp hour Eve cells. Got a slightly older production date, the 10th of September of 21. I did notice, looking at the BMS itself, it's got a February of 22 production date on it, so not terribly different. I have had these, the battery's been in my shop a little while, so that's probably part of the age, but a little bit older. Let's tap down the metal that I bent, and let's take a look at the cell pack itself, see if we can learn anything more from that. Okay, so right off the bat, I notice on the bottom we've got our heating pad. Looks like that pad is only on the bottom. Also looks like we're not going to be able to get access to the cells any more than we have already, because the whole cell encapsulation is welded together pretty substantially. And then over here, it looks like we've got our contactor. So let's take a look at 13 mil. At the contactor, and what we can learn from it. So we have a Tyco Electronics contactor, a V23130-C2021-A412. Yeah, so we'll go ahead and pull the specs in the contactor. Looks to be a pretty robust piece. The small wires coming off of it, it should be noted, are just for control of the contactor itself. There's no load running through them. The load is going to run through the larger contacts up here, which are plenty beefy, copper-plated tin-plated copper. Go ahead and put the relay back in. All right, that is, oops, the majority of the interior of the battery. Let's go ahead and put it back together. So we'll So that's a pretty good look at the MLi 1250 100 amp hour 12 volt battery from Mastervolt. The battery does indeed offer a lot of features, a very high quality build, extensive communications capabilities, but also comes at the more premium end of the market. So if you're able to leverage those features, it probably makes sense for you. On the other hand, if what you're looking for is just a lot of bulk storage, there are probably more cost-effective options out there.